Hello and welcome to Meclan 360. In this video, I want to solve a couple of problems with you to illustrate the concept of the moment of a force. So let's begin from this problem. All right. So the question is saying that we should calculate the moment of the 250 Newton force on the handle of the monkey wrench about the center of the bolt. All right. So this is the center of the bolt we are talking about. That is the handle. So how can I solve this problem? So we can use the principle of transmissibility and then the principle of moment. So principle of transmissibility and then the principle of moment. All right, so let's begin. Now the principle of moment is saying that to find the moment of the 250 Newton force about the center of the bolt, we have to resolve. So let's resolve this force into x and y component. So I will get a component in this direction and I will also get a component in this direction. Now, the 250 Newton is making an angle of 15 with the vertical. And what this means is that the y component is going to be cosine. So 250 cosine 15. That is 241.48. So what we are saying is that this 250 force is making an angle 15 with the vertical. Therefore, the vertical side is going to be cosine, and it is given by 241.81. 241.481, sorry. So 241.481. And then the x component is going to be sine. So 250 sine 15, that is 64.705. So 64.705 newtons. And this is also in newtons. Now, if I want to find the moment about the center using the principle of transmissibility, what I will do is I will try and then draw the line of action of the force. So this is what I will do. This is the line of action of the horizontal force passes through this line of action. Therefore, I just need a perpendicular distance from the center to meet this line. That will be the moment arm of this force. In other words, the principle of transmissibility is saying that I can even bring the force here. So I can trace the line of action of the force on a straight line. So I can even bring the force here, 64.705 newton. Therefore, I just need a moment arm. Is that right? And looking at it carefully, this force is going to cause a rotation which is going to be counterclockwise about the center. Let's say this is the center. This is going to cause some counterclockwise moment. So this is what we'll do. Summation of moments about C counterclockwise is positive. And then this one is going to be 64.705. I'm going to multiply this by 30 millimeters, which is the same as 0.03. Is that right? And then if I want the 241.481, the line of action is in this direction. The line of action of this force, let me draw it off. The line of action of the vertical force is always in this direction. Therefore, I just need a distance from the center all the way to meet the line of action. Is that right? Now, this distance must be the 200 millimeters. But the moment that this force creates, is going to turn in this direction, which is clockwise. So it's going to be minus 241.84, and then that is okay. So let me check. Yeah, 241.481. multiplied by 200 millimeters, which is 0.2. Then I can now find the moment. So it's going to be 64.705 multiplied by 0.03 minus 241.8 241.481 multiplied by 0.2. And if I do this, I'm going to get minus 46.355. So minus 46 point, let's say 36 Newton meter. The minus sign is just telling us that the moment that we just solved for is rather clockwise. So I will say clockwise, or so this is what we are saying. The moment, summation of the moment about point C, summation of the moment about point C is actually clockwise. And then we can either represent the clockwise by this, or we can write it as CW, meaning clockwise. Okay, so we've been able to solve for this problem at the moment. Let's look at another problem. All right, so let's look at the second problem. Let's read the problem together. So a man uses a crowbar to lift the corner of a hub. So a man uses a crowbar to lift the corner of a hot tube for maintenance purpose. Okay. So for maintenance purposes. And we are to determine the moment made by the 350 Newton force about O. So this is the 350 Newton force. We should neglect the small thickness of the crowbar. Okay. So the crowbar will have some thickness. And they are saying we should neglect that. Okay. So let's find the moment. Let's find the moment about point O. All right. So what I will do is that the first thing to realize is that, you know, this crowbar is making an angle 20 degrees with the horizontal. And if that is the case, then I can also see that by alternate angles, if I draw a horizontal here, then I expect that this should be what? 20 degrees. Is that right? Okay. Now, looking at it carefully, I can see that clearly I have 15 degrees here. 15 degrees here. Okay. So now this is what I will do. And let's not forget that this line here is actually perpendicular to the plane. This line here is perpendicular to the plane. And we know that the angle right here is what? 15. So this small angle is 15 degrees. So what should we add here so that we can get exactly 90 degrees? And that is what? So I'll get so 90 minus 20 plus 15. And it means that this angle here must be what? 55. Is that right? This angle here must be 55. Therefore, looking at it all together, we can say that the angle that the 350 Newton force makes with the bar is 55 plus 20, which is actually 75. So what we are trying to say is that this small angle here is 15. Therefore, this angle here must be what? 75. And this 75 is the angle that the 350 makes with the bar. Now, this is what we will do. We are going to resolve the 350 perpendicular to the bar and then parallel to the bar. So in other words, the line of action of the, so this is what we want to do. We are saying that this angle is 75 and we want to resolve this force along and then perpendicular. But what happens is that if I try to resolve the 350 Newton force along this, it's actually going to, the line of action is going to pass through point O, Therefore, it will not create any moment. But the component of the 350 perpendicular to the bar is the one which will create moment. I hope it's clear. So let's look at it. And this moment is actually going to cause a clockwise moment. And this moment is given by so okay, this is what we are saying. Let me do it this way so that you get it. We want to look at summation of moment about O. And we are saying that if I resolve this 350 force perpendicular to the bar, is going to be what? 350 sine 75. Is that right? We are expecting that we will get what? 350 sine 75. Okay, let me calculate it. So 350 sine 75. And that will be the magnitude here. And so this side is going to be 338.07. So 338.07. And then the side which is along the crowbar is going to be, that is 350 cosine 75. And that's going to be 90.587. So this side is going to be 90.587 newtons. But what happens is that if I want to take the moment, we are saying that this 90.587 is lying along the crowbar. And therefore, since the line of action passes through the crowbar, it doesn't generate any moment. However, the side which is perpendicular will rather create the moment. That's what we are saying. And it will create a moment which is clockwise. You know, the idea is to lift this bar. And if I apply a force which is able to turn in that sense, then I will be able to lift this up. Is that right? Okay. So then the moment is going to be 338.07. So minus 338.07. Then I'll multiply this by, you see, this time around, I've been able to resolve the force perpendicular to the bar. Therefore, I don't need to resolve the distance again. I will just multiply this by 0.65 meters, which is the same as what? 650 millimeters. And the answer that I will get here is what? So 338.07 multiplied by 0.65. And that's going to give me what? 219.746. So 219.746 Newton meter. And in fact, the minus sign is just telling us that it is clockwise. So I'll just bring the clockwise here. Also, I can either show this by drawing this sign, or I can write clockwise there. I hope it is clear. Let's look at another problem. All right, so let's solve this problem. Let's look at this problem. So the 30 Newton force P is applied perpendicular to the portion BC of the bent bar, and we are to determine the moment of P about point B and about point A. All right, so moment about point B is going to be simple because, you know, the force P is applied perpendicular. So with that one, we don't have to waste any much time here. It's going to be force times perpendicular distance, which is 30 times 1.6. And this force is going to come and rotate in this way. And that is what? Clockwise. So it's going to be 30 multiplied by 1.6. That is 48. So straightforward, 48 Newton meter clockwise. All right, so you can either write this as clockwise or you can write clockwise, the same thing. All right, so point B is pretty much simple and straightforward. But let's look at point A here. How can I find the moment of this force about point A? So I will apply the principle of transmissibility and then the principle of moment. What I will do is that, first of all, let's try to draw this a horizontal line here. By doing this, if this angle here is 45 degrees, is that right? If this angle here is 45 degrees, then it means that we should have 45 degrees here, isn't it? In other words, we are saying that this whole bar makes an angle 90 degrees with P. Is that right? So we expect that half of it will be exactly 45. If that is the case, then we want to resolve this P, which is 30 newtons along the Y and then along the X. Is that right? Now, why are we doing this? We want to resolve this so that we can take the moment of the individual forces. And this is what we are going to do. So I will do this. Now, this is actually the line of action of the vertical force. Is that right? And this is the line of action of the horizontal force. So what we'll be doing is that we'll just be taking distances. So let's start with the resolution. So the horizontal component is going to be 30 cosine 45. That is going to be 21.21. So 21.21 newtons. And then similarly, the y component is going to be sine. That is also the same thing, 21.21 newton. All right, so we have the forces. This is what we are going to do. We need to find the distance. You know, let me explain this. Let's say that I want to find the moment of the 21.21 newton force. This one. So let's say I want to find the moment of this force about A. Then what I will do is that by the principle of transmissibility, this is what we are saying. We need to find the distance from here all the way down here to A. Is that right? And so that is how we can be able to find the moment about A. We need to come all the way down here. That is what I'm saying here. That's what I'm saying. Is that right? Okay. So we know that AB is what? 1.6. So since we know that AB is 1.6, what we need to know is what? We need to find this distance. We need to find this distance. But what do we know? We know that the bar is what? 1.6. We know that the length of the bar, this one, the length of this bar is what? 1.6 meters. Therefore, and we also know that this angle is 45 degrees. Oh, and if that is the case, then this side will be what? 1.6 sine 45, isn't it? And that is, this portion from here to here. So what we are trying to say is that the line of action of the 21.21 Newton force, which is the horizontal force, is going to be what? 1.6 sine 45. And what is that? So 1.6 sine 45. And that is what? 1.131. So 1.131. So this distance here is 1.131 meters. In other words, okay, I think that is it. And then, so we've been able to do it for this guy. And then we also have to find the moment arm for the vertical force. In fact, the line of action of the vertical force is here. The line of action of the vertical force is here. This one. So we need a distance from here to meet this. And this distance is also the same as this distance here. So here we're going to what? 1.6 cosine 45. I hope it's clear. Because that distance here is actually the same as this distance here. So let's find the moment. Summation of moment counterclockwise is positive. It's going to be what? So with the horizontal force, it's going to be 21.21. And the line of action will create a moment which is going to be what? This force will create a moment which is going to be what? Come this way, isn't it? And then what we realize is that clockwise or minus, The line of action of the 21.21 force, which is the horizontal force, is actually the distance from all this way to this point. And so it's going to be 1.131 plus 1.6. And then there is this force here. But by the principle of transmissibility, I can even bring the 21.21 force here. So I just need a distance from here to meet this. We are saying that that distance is the same as this one, which is what? So the moment here is also going to cause clockwise movement. So it's also going to cause clockwise movement. That is what? So minus 21.21. But this time around, the moment arm is what? Cosine. So 1.6 cosine 45. So it's the same thing. 1.131. Okay, so what am I going to get? So we'll get 21.21 multiplied by 1.131 and then plus 1.6 and then plus 21.21 multiplied by 1.131, and I'm going to get 81.91. So 81.91 Newton meter. The minus sign here is just telling us that the resultant moment must be what? Clockwise. So the resultant moment must be clockwise. All right, I hope it's clear. So that is the resultant moment. Let's solve another problem. All right, so let's solve this problem. I believe that our friends who are interested in basketball will find this problem interesting. All right, so let's read the problem together. And in this problem, we are saying that an experiment or an experimental device imparts a force of magnitude F equals 225 newtons to the front edge of the rim at A to simulate the effect of a slam dunk. All right. So, like I said, our friends in basketball will understand this problem. Now, we should determine the moment of the force F about point O and about point B. Finally, we should locate from the base at O a point C on the ground where the force imparts zero moment. So, in other words, we are saying that this force F that we see here is 225 newtons. Number one, we should find the moment of this force about point O, which is this point, and then about point B. All right. And then we should also find a point somewhere from, let's say somewhere from, let's say a distance D from our O, our point O, where the moment is zero. All right. So let's start with the first part of the problem by finding the moment of what the force about point O. Okay. So I have a force triangle and I have this force. So using the force triangle, I can resolve this force into x component and y component. Now the x component is going to be 225 into what? That is 3 on 5. And the vertical component is going to be 225, that is 4 on 5. Now, someone will ask, where is the 5 coming from? So the small triangle will have a magnitude of what? 5. This is 3, this is 4. So this must be 5. Pythagorean triples. Therefore, if I have a triangle on a force, I can resolve this using that method. But then what is that? What is 225 multiplied by 3 on 5? 225 multiplied by 3 on 5. What is that? 135. So it means this is 135. And then 225 multiplied by 4 on 5. So 225 multiplied by 4 and 5, what is it going to be? 180. Okay. Now, I want to find the moment about point O. So I will use what we call the principle of transmissibility. So I will have to look out for the line of action of the 135 force. And this line of action is coming this way. And coming this direction, what I have to do is to just find the distance from this point to this point. And that distance is 3050 millimeters. Is that right? And similarly, if I try to locate the line of action of the 180 force, it's coming to it's going to come this way. Is that right? Now, by the principle of transmissibility, what this means is that I can even represent the 135 Newton force here on the same straight line. And similarly, I can even bring the 180 Newton force here, the same straight line. And the moment arm will be the distance from here all the way here. And that is what? 900 plus what? 700. So let's do it quickly. Summation of moment about O counterclockwise is positive. It's going to what? So if I pick the 135 Newton force, what is it? It's going to come, in fact, and it's going to cause a rotation in this sense. If I have a force here, look at this. If I have a force here and I have a moment arm here, this distance is going to cause a moment in this direction. And that is what? Counterclockwise. So it's going to be positive. And what is that? It's actually, this distance is going to be 3.050 meters. Is that right? And then I would look at the 180 Newton force. The 180 Newton force will cause a moment in this sense. And that is what? That is clockwise. So that is clockwise. It's going to be minus 180. And then the moment arm at this distance, which is what? 900 plus 700. So 900 plus 700. So 1600 millimeters. So that is 1.6 meters. So the moment about O is what? It's going to be 135 multiplied by 3.050 minus 180 multiplied by 1.6. What is that? I'm going to get 123.75. 123.75 Newton meter. Since it's positive, it means that it's going to be counterclockwise. And then it's so you can either write it this way or you can write counterclockwise, the same thing. So that is the moment about point O. The question said we should find the moment about point B. So let me clean everything. No, I will leave the forces and let me clean all these ones. So now I want to find the moment about point B. So we are going to use the principle again. If I want to find the moment about point B, I will draw the line of action of this force, which is 135, and that line is this line. The distance which is perpendicular to meet the point B must be this distance, which is what? 300 millimeters. But the moment is going to cause about that point is a moment in this sense, which is what? Clockwise. So it's going to be minus 135 minus 135 multiplied by 0.3 meters, which is the same as what? 300 mm. And finally, if I want to find the moment of the vertical force, which is the 180, in fact, that distance is here. The vertical force, I need the distance from here to here. And that must be what? 700. Is that right? And therefore, I'm going to do what? But it's going to also be what? Clockwise. So minus 180 into 0.7 meters, which is the same as 700. So what is the resultant moment then? So the resultant moment is going to be minus 135 multiplied by 0.3 minus 180 multiplied by 0.7. So 1665 minus 166.5, sorry, Newton meter. So the minus sign is just telling us that the moment there is what? It's actually clockwise. So I can either do this or you can write clockwise. They are all the same. So we've been able to solve the moment about point O. Finally, we were asked to find a point at point C from the ground where the force impacts zero moment. Okay, so let's do that one and then let's end the problem. So let's say that there is a point C here. We don't know. Okay, or let me bring it. Let's say a point C somewhere we don't know. We are saying that the summation of moments about C is zero. That is what we are saying. So let's do that. Quick one. So counterclockwise is positive. We want to sum moment of this force about C. Now looking at the line of action of the force, the 135 force is coming this way. So the perpendicular distance will be this distance. And that is what? 3050 meters. So it's going to be that is the force, which is 135 and then 3.050. Now it must be noted that this 135 force causes a counterclockwise moment, so it's going to be positive. But looking at the 180 Newton force, it is coming vertically downwards. All right, so let's look at the line of action of that force. So considering the 180 Newton force is coming this way, and we need a perpendicular distance. We need a perpendicular distance from C to meet this, and that is what we are calling the D. Or let's say a point D, a point C, and the distance is D, and that's going to cause a counterclockwise moment. Is that right? About that point C. Sorry, clockwise. This is going to cause clockwise. It's going to be minus 180 multiplied by D to be 0. Solving for D, we can say that D is going to be 135, 3.050 divided by 180 degrees. And what is that? So that is going to be 135 multiplied by 3.050. Then I'll divide this by 180. So the value of D that I will get is 2.288. Let's say 2.288. So 2.288 meters. Now, sincerely speaking, the whole of this distance from here to here is actually 1.6 meters. It's actually 1.6 meters. So if we are having a distance here which is greater than that, then it means the D is not actually a certain point here. But technically speaking, it must even exceed this. It must even exceed this. So let's say the point C is somewhere here. But we know that the whole of this distance here is 1.6. So what should we add so that we can get the distance, which is the 2.288? And then what happens is that if I want that distance, clearly I can say that, so let's call that distance x, this small distance. But I know that x plus 1.6 will give me the 2.88. Therefore, x is, if I subtract what? 2.288 from 1.6. And I'm going to get 0.688. So x is going to be 0.688. So therefore, it means that the point where the moment will impact the point where the force will impact no moment at all is a point C, which is what? So let's say 688 millimeters from the pole. So from this distance. Okay. So somewhere, so that is the point here. And we are saying that this distance from here to the pole is what? 688 millimeters or 0.688 meters. All right, so thank you very much for watching.